Welcome to the video on the combined gas law. Um, Basically, the combined gas law is what it states. Combined means that it's putting the laws that we have discussed. If you've been watching this series of videos, we've talked about the Boyles, Charles, and Gay-Lussac's law, and it combines them into one law. And what I'm going to show you through this video is that you can actually commit to memory one equation, and it's called the combined gas law equation, and you can use it to solve any of the problems that we've been doing so far. Okay, you can of course memorize all four of them, that's fine, but I'm going to show you how that works. But if you take all three of our gas laws and you combine them into one equation, you get P1V1 over T1 equals P2V2 over T2. So if you look back at the three that we've looked at, you just put them together. Okay, and so we can use these to determine the effects of changing two factors, so pressure and temperature on the a third factor of volume. So, but we still have to be given all variables but one. Okay, so you can solve for any of these variables, P1 or V2, or the list goes on. I have found with my students that they have trouble rearranging this equation when solving, and they often get the answers incorrect because they didn't rearrange correctly. I'm going to show you a linear equation that it's the same thing, these are equal, but my students typically rearrange it better. So P1 V1 T2, so star that 2 there. 2 means final temperature, equals P2 V2 T1. Okay, this is what I use in class because, like I said, it seems to prevent some mistakes with rearrangement. Remember, P, pressure, V, volume, T, temperature. The ones and the twos, the ones are for initial, T's are for the final of those quantities. Okay, so here's our nice summary table, which this is great. So Boyle's law, if pressure increases, volume decreases. And there's the equation. Charles' law, temperature increases, so does volume. And Gay-Lussac's law, direct relationship again. If temperature increases, then that makes the pressure of those gas molecules increase. If we put all of these together, we get the combined gas law, which I'm going to write it again. If you like looking at it better this way. Okay, but you've got to be sure that you plug in T1 and T2. Don't get those backwards. Okay, it's P1 V1 T2 equals P2 V2 T1. Okay, we're going to do two problems using the combined gas law. And I've got the answer already up here, but I want us to kind of dissect the problem first. Okay, we have 260 milliliters, so this is V1. There's T1. Okay, and we know we're going to have to add 273 because all of our gas law equations have to be in Kelvin. So that gives us 305 Kelvin. Okay, we have a pressure of 0.500 atm. So that is P1. We were looking for what temperature? So we're looking for T2. Here's V2. And here's P2. Okay. I did this problem on purpose because in the combined gas law, it is okay for you to use milliliters or liters as your units, and you can use ATM or torr, and torr and millimeters mercury have the same units, so either of those, but you have to be consistent. So here we have ATM and torr. Okay, you cannot plug those in that way, okay, because they're not consistent. You have to have the same for both. Okay, so for this problem, I'm going to take ATM and convert it to torr. So if I take ATM and 1 ATM. There are 760 torr. Okay. So this gives me 380 torr. All right, so I'm going to change that to 380 torr. All right, I'm going to show the whole answer here as well, but now that I've dissected it, I want to just plug in for those variables based on my equation. So I have P1, V1, T2. P1, V1, T2 equals P2, V2, T1. Okay, I'm solving for T2. So I've got to divide here. So all I'm doing is rearranging the equation. Okay. Now I just plug in. So give myself room here. P2 is first. So P2 said was 1200 torr. V2 was 500 milliliters. T1, that's where you got to be careful. T1, your initial temperature is 305 Kelvin. So you're going to multiply all three of those numbers together. P1 is 380 torr. Okay, we converted from ATM so that we would be consistent. Okay, you could have converted from torr to ATM. That's fine as long as you're consistent. And when you plug it in, you'll get the same answer. Okay, so it could be torr or ATM there. And then V1 is 260. So when you do the math, multiply 1200 by 500 times 305 divided by 380 times 260. Okay, and you should get torr cancels, milliliters cancel. You're left with Kelvin, and that's what we're looking for is T2. And so your answer should be we're to 3 sig figs here. Okay, so we get about 1,850 kelvins. Okay, this is also shown. I know it may be hard to see for you here. So technically, for sig fig reasons, we get about 1850. All right, and now I'm quickly going to show you how you can use the combined gas law for all of your problems so far with Boyle's law, Charles' law, Gay-Lussac's law, and just kind of helps with memorization purposes. So, but if we know our combined gas law, P1 V1 T2 equals P2 V2 T1, and like I said, I like the linear version. Just I think you all can rearrange it better. Okay, this problem here, if you read it closely, you can pause and read it if you need to, but it's just Boyle's law. So you could recognize it as Boyle's law and just use it that way. So it's a real simple problem. So we have 12 liters and 1.2 ATM, and then we double the pressure. So we're going to half the volume. That's what Boyle's law says. If we increase pressure, we decrease volume. So if we have 12 liters and we double the pressure, we're going to cut that volume in half. So the answer is 6. Okay, but we're just going to use the combined gas law to see this. So we want to find volume V2, and it says here if temperature and number of moles are held constant. So everything else is constant. Okay, so I would look at this and say, okay, well, it says temperature is constant. So if you wanted to plug in a number there, you could put 1 and 1, okay, or 273 and 273, or it doesn't matter because it's going to cancel. So if something's constant, then I can just cancel it out, okay? Therefore, now I have Boyle's law. P1V1 equals P2V2. And so I would just solve. So we're looking for V2. So we're going to have P1V1 over P2. So P1, 0.2 ATM, 12 liters. P2 is 2.4. It doubles, so 12 times 1.2 divided by 2.4 equals 6 liters. And that's what we expected. Okay, and like I said, you could put in numbers there if it's constant. Just put, 1 and 1. It doesn't matter because it's going to cancel in your equation, or you can just cross it out. Okay, but for all three of our laws, Boyle's, Charles, and Gay-Lussac's, you can use this equation and just cross out if something is constant. So if pressure was constant, then you could cross it out and go from there. All right, I hope this helps and simplifies things, and I'll see you soon.